All right. So here we're beginning with our paper one, and I'm gonna do questions for you. So, um, I want you to just master the binomial theorem, then AP and GP for once. Okay? Are you ready? Then we do questions. All right. So when these are different topics, AP and GP, we call them the progressions. Okay? These are progressions. So AP and GP are progressions. It's not the same as binomial theorem. Are we together? These are progressions, which we actually call sequences. And I'll show you the major difference between them in the binomial theorem. But now, when you're dealing with AP and GP, AP, we know that it's arithmetic progression, and GP is geometric. These ones, you're going to get the formulas in MF19. So you're going to have the formulas, and the trick is about you using the formulas. And I'll show you how you use the formulas as we are doing the first few questions. So you should know that for AP, first is how do you find an unknown term? An unknown term is A plus n minus 1 d. This you're going to have, okay? This is how you find an unknown term. Now, you must know that A is your first term, the first term in your progression. And then D is common difference, which means it is T2 minus T1 or T3 minus T2, etc., etc. You understand? So you say the one in front minus the one behind, you get D. So you must know how to get D. Once you have D and you have A, you can find the unknown term. Okay? So we'll be wanting to find what is the 50th term. If we keep following this order, how do we get the 50th term? How do we get the whatever? This is going to be how you do it. Are we together? Right. Now, the other thing you must know how to do on your progression, on your AP, is how to find the sum. And there are two formulas for sum, and you must know them both. But remember, you're going to be given. So it's not a big deal. It's actually not a big deal for us to say, oh, let's cram the formulas in. You'll be given MF19, or you're allowed to get with it into your test or exam. So it's not a problem. But you must just know the formulas, right? So the formulas are two, which is n over 2, 2a plus n minus 1d. By the way, when you say n minus 1d, it just means the d is one step behind where you are. So if you want to find sum of 50 terms, here you'll be saying 49d, okay? Which is the same here. If you want to find the 60th term, here it would be 59d. So it just means d is one step behind all the time, okay? Whether you are finding an unknown term or you are finding the sum, it's going to be the same thing. Can you see that? All right. So this formula you'll be given, and the other formula for sum you also be given, which will be just n over 2 a plus l, where l is the last term of your progression, okay? If you know the last term and you know the first term, then you can use this one. All right? Are we together? All right. So, excuse me. Give me a second. Sorry. I think the traveling has affected me a little bit. Your country is moist. You understand? So now the other thing we're doing is GP. So for AP, we are done. Have you seen all the formulas? So there should be nothing for AP we are not able to do. We'll do the questions. Then now for GP, the formulas will be, how do you find the term you don't know? Tn is, it's now, instead of A plus n minus 1, it's AR to the n minus 1. And remember this, you'll be given again. It's AR to the n minus 1. When we say r to the n minus 1, we're just saying the power of r is one step behind where we are, okay? So in other words, if you want the 50th term, it will be AR to the 49. You understand? Where A is the first term. So A is the first term. So this is not going to be hard. You can find it. Then R, how do you find R? To find r, you divide the term in front minus the term behind. You understand? T3 over T2 or T4 over T3 or whatever. You just take the one in front, you divide. For D we were subtracting, for r you divide. Okay, to find it. Then you must know how to find the sum. Okay, the sum. The sum will depend on who is bigger, 1 or r. So it says a, then it says rn. You have a, then you have rn. So if we never want the denominator to be negative, basically. So if 1 is bigger than r, that means you're going to say sum Sn will be a multiplying 1 minus, because 1 is bigger. So we always start with the bigger one. So it's 1 minus r to the n over 1 minus r. Okay? If r is bigger than 1, which is very rare, then you have Sn be equal to a, then r to the n. Okay, there's a, then r to the n minus 1 over r minus 1. Can you see for Sn, the two formulas? Then there's the last one, which you meet again for your geometric progression. This is when if r is a fraction. If r is a fraction. In other words, the modulus of r is less than 1. So if r is a fraction, a proper fraction, then what you'd say is sum to infinity. Isn't here we had r greater than 1? Then here we had r less than 1, right? Okay, when we had r less than 1, the thing of it is now, here we are going to have r, the value of r, be a fraction, okay? So it's between 0 and 1. So what you do is you are going to say, here's how you do it. You say S to infinity is going to be a over 1 minus r. Okay? Sum to infinity. So, these formulas you're going to be given, but I've just given them to you. This is everything you got to know about AP and GP. And now what you'd need to do is questions. Okay? If we do questions, let me look for it. Question after question for AP and GP and stuff. So I'll show you how easy it is. All right. Here is the geometric progression. Can you see? So how you actually answer it is, you'll be knowing the formulas. You know all the formulas for GP. You wrote them down. You have them where you are right now. So you know that Tn is a r to the power n minus 1. You know the formulas for sum. Okay. A multiplying 1 minus r to the n over 1 minus r. That is if 1 is bigger than r. Then if 1 is less than, Sn will be a times r to the n minus 1 over r minus 1. If r is bigger than 1, then you have S to infinity is now a over 1 minus r. Now, these are the formulas. So you have them. But now the secret is, for you to get these and answer these questions, you have to, only these four formulas you have. You have to write down what they have said as a formula. So you're not allowed to just write down, to just read. Everything you read, you have to write it down as a formula. Are we together? So here they said in a geometric progression, okay, fine, is such that the second term is negative 120. Ma'am, you are not allowed to read this and pretend like you didn't see it. Write it down. What did they say? They said second term is 120, is negative 120. Okay? So the first thing you should do is write the formula for second term. You know that Tn is equal to AR to the n minus 1, right? So second term will be AR to the 1, which will be just AR, okay? Because it is to the 2 minus 1, which means the second term is AR. Is it true? And they've said, what is your second term? What is it? It is negative 120. So you put negative 120 is equal to AR. You got to write it down. That's what they said. So negative 120 is equal to AR. We can skip a line. We can use it whenever we're going to need it. Now, they said sum to infinity is what here? Remember, they've said the sum to infinity is what? Sum to infinity is 160. You can't pretend you didn't see that. You know the formula for sum to infinity, so you got to write it down. Sum to infinity is equal to, put the formula first. Don't worry about the value they've given you. Put the formula first. It is A over 1 minus R, right? So what you can do here is, you can now make A the subject here so that you can come and replace here. You understand? So you can say, take R to the other side. You have negative 120 over R is your A. Can you see that? So we'll come here and say, sum to infinity is equal to, instead of A, you say negative 120 over R divided by 1 minus R. You see that? We have replaced A because we know what A is. So we've put this part here. We've put it here where A was. And it's over 1 minus R. Now, we know what sum to infinity is. They said it is 160. So you say 160 is equal to, when you have two denominators, the denominators will multiply each other, okay? So it's negative 120 all over R multiplying 1 minus R. Okay, you have seen that? Good. This is what we're going to do. Now, excuse me, we expand it. 160 is equal to negative 120 over R times 1 is R minus R times R is R squared. Do you see? Good. So you now have it like this. You have to break the fraction, ma'am. You have to break the fraction. So you can take R minus R squared to the other side. You can swap it with 160. So you have R minus R squared is equal to negative 120 divided by 160. R minus R squared is equal to, here you should get an answer. What is it? Negative of 3 over 4. Okay? Basically. So, you can see that we have a quadratic equation. We have to solve it. That's where you get your 4 marks. Because you have this R squared. So it makes it quadratic. So, you take the R squared to the other side to make it positive. You have 0. Because one side should have 0. It will be now equal to R squared. Then this R comes, it's now negative minus R. Then minus 0.75 or 3/4. Do you see it? You use the quadratic formula. R is equal to, you say you can put your A. A is the number before R squared, which is 1. B is the number before R, which is negative 1. C is the last number, which is there alone, which is negative 0.75. So you say now R is equal to minus B plus or minus the square root of B squared minus 4AC all over 2A. This is now quadratic stuff. It's nothing to do with progressions. Can you see that? But the secret was, whatever we read, we converted it to a formula. You saw that. So now you say R will be equal to minus of B is minus of minus 1. Plus or minus the square root of B squared. What we always want to do is find B squared minus 4AC. It's always the first thing we like to find most of the time. What is your B? Negative 1. All squared minus, you open bracket, 4 times A. What is A? 1 times C, negative 0.75. What do you get? It is That's the discriminant, right? B squared minus 4. Negative 1 all squared, 1. You can punch it in the calculator, then minus this stuff. So put it in your calculator, tell me what you get. You got 4. Okay. So this is 4. So you can now say your R is equal to minus of B, which is minus of minus 1, plus or minus the square root of B squared minus 4AC, square root of 4, all over 2A, which is 2 by 1. So there we go. R is equal to 1 plus or minus root 4 is 2, all over 2. So you get it as 1 plus 2 over 2, or 1 minus 2 over 2. You get R equal to 1 plus 2 over 2. That's 3 over 2. Or your R is negative 1 over 2. You see? Which R can never be negative. So it is going to be this. You found it. Okay? Now you can go to the next one. Give me a second. I need to sneeze. Wow. We have the R. So find the sum to infinity of the remaining terms. The first 9 terms of the progression are now removed. Can you see this? So they say the first 9 terms are removed. So which one is now your first term? Basically, that's just what is changing. R is not changing. If we're removing the first 9, that means the first term is now the 10th term, which is a R to the power of 9, right? 10th term is a R to the power, which is going to be, do we know our A? We should be knowing our A, do we? Maybe, I don't know. Yes, A is negative 120 over R. So you can say A is equal to negative 120 over 3 over 2. Okay, over R, which is negative 120 divided by 3 over 2, which you divide by a fraction, you multiply by the flip. So it's negative 120 times 2 over 3, which is 240 divided by this, becomes negative 80. So our A is negative 80. So we can now say negative 80 multiplying what is R? R is 3 over 2 to the power of 9, because it's the same progression. So what is it? You punch this. Punch this, let's see. Okay. If we go back here, let me think. There's something I need to check. I need to check if R can be negative. I want to check if you can have R be negative in a geometric progression. Because there's something that is interesting me, which is the R for sum to infinity. When we say that its modulus should be less than 1, which is like to say it should be a fraction, right? A proper fraction. Something like that should be a proper. if it's more, it means it can never be bigger than 1. But 3 over 2 is bigger than 1, right? Can you see that? So that means we picked the wrong r. The r was actually the other one, 1 minus 2 over. You understand? So r can be negative. But because you know why I'm saying that? Because this one has a sum to infinity, so it cannot be bigger than 1. Do you get it? So 3 over 2 is definitely not the answer. It's actually the other one. So we have r will be 1 plus 2 over 2 or 1 minus 2. And this is the correct one. This is the wrong one. Wrong. That means the correct is r is equal to 1 minus 2. That's minus 1 over 2. You get your r. So our r is actually negative half. Okay? Negative half, which means we multiply by negative 2 over 1, which means this will become positive 240. Okay? So now we will say this is going to be 240 by negative half to the power 9. Tell me what you get. 9. You say 240 by negative half to the power 9. You got negative 15 over? Right. Can you check with your marking key? February, March 2025, paper 1. Number 8B. What is the answer? Negative 5 over 16. Isn't that like the same? No. Oh, okay, yeah, you know what? Yeah, this is not the answer. We found the first term, but they said find the sum to infinity. So basically, we know that our a is now negative 15 over 32. That's just what we've been finding. So a, which is the first term, is now the 10th term. That's what it means to say you're removing the first 9 terms, so this one. So now you just say the sum to infinity becomes 1 over a minus r. You get it? We still use the same sum to infinity term, and we find it and we're done. Okay? So that's basically what we had done wrong. Okay? So it's like we go for it. What is it now? Negative 15 over 32 divided by 1 minus r, which is negative half. So it's like put this in the calculator. Remember, what calculator are you using? Okay, good. So make these fractions. Okay, which is the same as the answer in the marking key, right? Good. So you get your marks. So the secret is actually on 1, writing what they've said. So when they say the first 9 terms are now removed, that means the first term is the 10th term. That's basically what it means. So you have to write that down, okay? Then from there, you can now go to sum of infinity, sum to infinity. Then find it. And make sure you know your A because you are not given, okay? And you know your A by using the formula which is there here. Negative 120 over R. So you show it by this, then you find your A. And this is the old A, okay? Now you need the new A, which you find by this. So this is A old. This is the new A, which is the 10, which is like this. Anyway, good. So A new, that's the one you're going to use in the sum to infinity. And yeah, you're done. What is the other thing? Are you getting a hang of it? Do you want to see more? You're fine now. All right. What is the next one? Binomial? Right. Let's do the expansion here. So, when you're doing binomial expansion for AS, I can give you the formula that works for A2 and AS, but I would love to give you the one for choose. It's going to be there again in your MF19. So let's go to it. Then I just show you something. I want to go to MF19. And what we're going to do in MF19 is we're going to see here. Can you see the binomial series? All right. Now, here you're going to be given the one that works for positives. Okay? And then you're going to be given this one that works only when you have been given one. So there is one more which is missing, okay? Which is, what do I do if this is not a 1? But I'll teach you that for P3, okay? I don't want to put it for you right now when you're doing AS. But for P3, this one, the reason why we use this one is it works when you have, it works when n is negative, okay? But this one here does not work when n is negative. So we must do the situation for this, for when n is negative, okay? Now, look at this. And you can see that the formulas I've given you are there in the MF19. Here we want to use the binomial expansion, so we're going to be using this one, a plus b to the power of n, okay? So this one is not hard because you can literally, you'll be having your MF19, so I'm going to, let me do it like this. Then, right next to it, I open again the past paper. So, you'll be having it. Now, here they want you to just do the complete expansion of this. So, this one is easy, right? Because you're going to get up to when you have the power being 4. Okay? So, you're going to say, you write the formula. Write this formula, okay? You say a plus b to the power of n is equal to a to the n plus n choose 1, a to the n minus 1, b to the 1. You see? Plus n choose 2. So simple. A to the n minus 2, b to the 2. So you should know that it just starts with a to the n, then it moves from there, okay? Plus n choose 3, a is now to the what? N minus 3, right? Then b is now to the 3. It keeps going until it goes to 4. Plus n choose 4, a to the n minus 4, b to the 4, right? So what you would now say, you would just say a is 2x, b is negative 3 over x, n is 4. Can you see that? So you'll be now just now putting below. Everything is easy. You can now put to say, so that means 2x minus 3 over x. This is binomial expansion, okay? To the power 4. This is going to be, what is our A? We are putting this. What is our A? 2x. And what is n? 4. So if it's a to the n, it is 2x to the 4. You see it? That's why you must first rewrite the formula from the book. Can you see that? Then you now say plus. What is our n? It's 4. So it'll be plus 4, choose 1. Can you see that? Then what is our a? You already know our a is 2x. So it'll be now 2x to the n minus 1, which is to the 4 minus 1, which is to the 3. Right? And then you now have b to the 1, which is negative 3 over x, and it is the power of 1. Can you see that? Plus 4, choose 2. You now change here. A is to the 2x. 4 choose 2. Then 2x is to the n minus 2, which is to the 4 minus 2, which is 2. Then b, negative 3 over x, is to the 2 as well. You understand? Plus, you keep going. 4, choose 3. A is to the n minus 3, which means a, 2x, is to the 4 minus 3, is to the 1. Then b, negative 3 over x, is to the 3. Finally, plus 4, choose 4. A is 2x. It is to the 0, 4 minus 4. B is to the 4, which means negative 3 over x is to the 4. Do you see? So now, can you find me answers? Let's go for it. And we are done. What is 2x to the 4? 2 to the power of 4, 16, x to the 4, plus, what is 4 choose 1? Can you do choose? Second function 4, something, shift 4. 4 choose 1 is 4. Then you multiply by the other numbers, which is by 2 and which is by 2 cubed, which is 8. 4 by 8, that's 32. By negative 3, what is it? Negative 96. Okay? So you can just concentrate on the numbers. 4 choose 1 times 2 to the 3 times negative 3. You get negative 96. Then it's all over. You now have the x. X to the 3. There we go. Then divided by x to the 1, which is just x, which means it will become x to the 2. Do you see that? Then plus. Now what is 4 choose 2? Then multiplied by 2 squared. Multiplied by, in brackets, negative 3 all squared, which is 9. Multiplied by 9. Wow, sorry. Multiplied by 9. 216. Now let's see what happens with x. This is x squared, then divided by x squared. Can you see that? So it's x squared divided by x squared, which is just nothing, right? Okay. Plus, now we come for this one here. What is 4 choose 3? 4. And then times 2. Then times, then times negative, multiplied by negative 3 all cubed in brackets. Put negative 3 all cubed in brackets and tell me what you get. It's like by negative 27. What do you get? 72. So this is a positive 72. Now what about x? Here you have x to the power of 1 in the numerator. In the denominator, you have x to the power of 3. So it's x over x to the power of 3, which means you have x to the power of 2 in the denominator. Can you see that? Plus, now let's do the last one. 4 choose 4. – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . – 4 . 1 again. Okay, great. Then this is also any number to the power of 0 is 1. So it's by 1 again. So now let's do for here. Can you say negative 3 in brackets to the power of 4? What do you get? Isn't you got 1 here? This is also a 1. So we now need to find out the numbers. So for the numbers, we'll say this negative 3 in brackets, okay, to the power of 4. What do you get? 81. Okay, so it's going to be 81 divided by, this is x to the power of 4. So it's x to the power of 4 in the denominator, right? Okay, good. So you have your solution. Good. Don't forget to write the series first from the formula here. Then you put yours below, okay? Now look at what they are now saying. Determine the coefficient. This is where binomial expansion is important for AS. For AS level. It's the coefficient when they give you things like this. Okay? So, they want the coefficient of what, ma'am? Of x squared, right? So, how do you get, isn't we have already expanded this? Binomial expansion helps us to expand this, right? So basically, we have x squared plus 5. In reality, it's multiplying this whole thing, okay? So what we have, you can write it with your pencil to say, I actually have x plus 5, x squared plus 5 rather, multiplying this, which means it is multiplying 16x to the 4 minus 96x squared plus 216 plus 72 over x squared plus 81 over x to the 4, right? Now, they think we don't know algebra, but obviously we know algebra. We know that when you're multiplying two brackets like this, it's everything in here multiplying everything in here, right? So x squared is going to multiply everything, right? And 5 will multiply everything, right? Now, we are only interested in the things that will come out with an x squared. Do you get it? Because that's the one we want coefficient of. So how do we get x squared when this x squared multiplies this bracket? Who do you have in this bracket who will multiply by x squared and come out with an x squared? To 16. So the coefficients we have 216 by x squared, which is 216x squared, right? For coefficient, we'll only take the x, the number. But first I'm putting with the x squared, right? Plus, who will give us x squared when 5 multiplies this whole bracket? Negative 96. So what is negative 96 by 5? Negative 480 x squared. Don't be fooled by this. This is not an x squared. This is an x to the negative 2 because the x squared is in the denominator. So yeah. So these are the things. So we will say coefficient. So here these are terms with x. Okay? Terms with x squared. You can write it like this. Terms with x squared. So you add, you can subtract them. You say this is equal to, what is 216 minus 480? Negative 264. You said negative 264. X squared. There we go. So now you can now say coefficient is only the number, right? Is negative 264. You have seen it? Good. Questions? Good. Now, what is the next thing? Which one should you do? What is the next thing? Trig. So let's go to it. Oh, here's another AP. Can you do this one? What is the secret when you're reading? Read it and tell me what to do. An arithmetic progression has first term 5, common difference 6, blah, 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 blah. It keeps going. What is the first, what are we going to be doing when we're answering this? What is the most important thing that you must do when you're doing progressions? Yes, you must write down everything you're reading. Well done. So here you read it as first term 5. So what are you going to write? A is equal to 5. Well done. Now, common difference 6. So you write D is equal to 6. Can you see that? Good. Now we say now, for this progression, find the sum of all terms that lie between 150 and 400. So this is a very interesting one. Find the sum of all terms that lie between 150 and 400, right? All right. So you try to see term number 150. Is it there in this progression? Remember, the progression is Tn is A plus n minus 1d, right? Which means it is actually Tn is 5 plus n minus 1 by 6, right? So can we try 150 and see if 150 is there in this progression, okay? 150, is it there in this progression? So we'd say, if we tried with your pencil before you write it officially, you'd say for Tn we are putting 150. So 150 is equal to 5 plus n minus 1 by 6. Then we see if we'll get a whole number for n, okay? 5 goes to the other side. It will subtract. 150 minus 5 is equal to n minus 1 by 6. 145 is equal to n minus 1 by 6. 145 over 6 is equal to n minus 1. So 145 over 6 plus 1 is equal to n. What's 145 divided by 6? Yes. Do you get a whole number? You don't get a whole number. Oh. So that means 150 is not in this progression, right? Let's try 151 in this progression. If we put 151, this becomes 146. What is 146 over 6? So it's not again. What is one? Let's try 152, which means this would be 147. What's 147 over 6? 49 over 2, which is again not. So let's try 153. 153, which makes this 148. What is 148 over 6? Whew. What's 149 over 6? What's 150 over 6? What is it? 25. All right, so this should be 155. So the first term which is up, which is between 150 and 400, is actually 155. You get it? So that when you say 155 minus 5, you get 150. So it's like this. This becomes the very first term, okay? So you have the very first term is 155, and then the very last term will be what? So let me just refer. Give me a second. I want you to see this. You should practice and master. So basically, what we had to know is what is it that we write when we are looking for terms between 400, 150 and 400. How do you find how many they are? That's all we have to do. Okay. You have to find how many. Here you get your n being what? If it's 1, you said 150 divided by 6 gives you what? 25. So it's 25 plus 1, which is n, so 26. So this is the 26th term, right? So we now have term number 26, and now we need to know. So you can write it here to say 155. You say here, let Tn be equal to 155, okay? Which means we want the term number to be 155. So term number 155. We don't know what it is. We let Tn be 155. We don't know what term number it is, okay? 155 will be 5 plus n minus 1 by 6. 155 minus 5 is n minus 1 by 6. 150 is n minus 1 by 6. 150 over 6 is n minus 1. 23 is n minus 1. 23 plus 1 is n. 24. You said 25, right? It's actually 25. 25. Okay. So 26 is our n. Now we need to find the term that it shouldn't be bigger than 400, okay? So remember, we are starting from 150 going all the way to 400. And we want terms that are in this sequence, okay? And we saw that the first term that will be in this sequence will be term 155. Okay? Now, we want the next term that will be, it has a value of 155. Now, we need the next term that will be in this sequence. What value will it have? What term is that? Can 400 fit in this? What is 400 minus 5? Then divided by 6. Do you get a whole number? Shame. So what is 399 minus 5? Then divided by 6. Not a whole number. 398 minus 5 divided by 6. Huh? Not 397 minus 5 divided by 6. $396 minus 5 over 6. $395 minus 5 divided by 6. Good. So that means the last term in this range is 395. Okay. So you say again now, Tn is equal to 5 plus n minus 1 by 6. So I want you to say, we want to say Tn, we take 5 to the other side, it subtracts, is equal to n minus 1 by 6. You can say Tn minus 5 divided by 6 is equal to n minus 1. Then you say Tn minus 5 divided by 6 plus 1 is n. Then you say let Tn be equal to, what did we make it? 397, right? What was it? 395. Okay, be 395. So you now say 395 minus 5 divided by 6. What is it? What did you say your answer was? Your answer is 65. Yes, so it's 66 is your n. So we have from 26 to 66. They want the sum, right? So you say, what is 66 minus 26? Okay. 66 minus 26 will give you 40. Okay. So n is equal to 40. So you can say n, the n you want. So it's 66 minus 26, which is 40. So you can say Sn is equal to n over 2. Since you know the first term and the last term in this progression, you can still do the a plus l, okay? So you say sum of 40 terms, which is 40 over 2. Our first term we saw it was 155, right? Plus our last term we saw it was 395, right? So you just put it like this. You find your sum of 40 terms. Sum should be big because it's the sum. $3,800 and what? Okay, 818. Good. Are we fine? Everything okay? Did you see? So now we do trigger. Pardon? Okay. Right. Let's go to the trig. Let's see the one that could be giving you problems. Where is it? This one? Identities? Identities? All right, so for identities, you just need to do it step by step, okay? So show that this gives you this. You just do the true things step by step until you get to what it is, okay? So can you see that plus 5 sine squared theta? Can you see that the final solution does not have tan? So we already know we should change tan, right? So let's change it. This becomes 3 by, what is tan? I want you to only use AS level identities in this paper, okay? Remember the AS level identities is that tan theta is equal to sine theta over cos theta, right? Then sine squared theta plus cos squared theta is equal to 1, right? And this one, we actually use it in a different way, but I'll show you most of the times. So here you'd say, let's remove tan squared. So it's going to be sine squared theta over cos squared theta, right? Because it's tan squared. Then plus, this becomes 5 sine squared theta, right? Which is going to be equal to, we should go step by step until we get this. Can you see it? So this becomes 3 sine squared theta over 3 cos squared theta plus 5 sine squared theta. You see? Then, can you see that this is 1 minus sine squared? So this is why I said this version, I'm giving you a tip. This version is normally not used in this form, okay? The form that this is used, we know that sine squared plus cos squared is 1. But the form that it is used is, if you want to get sine squared, you'd say 1 minus cos squared, okay? If you want to get cos squared, you change it to 1 minus sine squared, something like that. Can you see that? Because you'd have taken sine squared to the other side, okay? This is the version we normally. So what you're going to see is that there is no cos squared here. Is there cos squared? It's not there, right? So we need to remove this cos squared, right? So this becomes 3 sine squared theta over 3 multiplying 1 minus sine squared again, theta. Because we have changed cos squared to be 1 minus sine squared. Can you see that? Then plus 5 sine squared theta. Can you see that? Then now, can you see that it has a common denominator? Can you see that they have a common denominator? So you just put the common denominator. You should be done very soon. So basically, first of all, let's simplify this. 3, wait, I lied here. When you multiply by 3, it only multiplies the top, okay? It only multiplies the top. So when you multiply by a whole number, it only multiplies the top. So the 3 is only at the top. So we have it like this. Now we put the common denominator. The common denominator is 1 minus sine squared theta. So we'll say 1 minus sine squared into this. You just get 3 sine squared theta, okay? Plus, okay, because you'd say, basically what you'd say 1 minus sine squared into 1 minus sine squared is 1. That 1 you multiply by this, it doesn't change. Plus, this is like saying this is over 1, right? You say 1 into this, you get 1 minus sine squared theta. Then it should come and multiply this 5, okay? 5 sine squared theta. I think by the time you simplify, you'll be having your answer. So this becomes 3 sine squared theta plus, here you have to expand. So 5 sine squared multiplies 1. It becomes 5 sine squared theta. Then 5 will multiply this negative. It becomes minus 5 sine to the 4 theta. And it's over 1 minus sine squared theta. Can you see that? This becomes 3 plus 5, you get 8 sine squared theta minus 5 sine to the 4th theta, all over 1 minus sine squared theta. You see? Did you see it? So the secret for identities is they solve themselves. Just follow steps and try to look at the answer and see what you're supposed to remove. And you'll be removing using just these. Okay? Good. Now, where is the point? Hence solve. So if they say hence solve, you use the answer. You always use the answer. If you can't get it, you use it from here, the one which they say it shows. So you take this. Okay? So they say hence solve, then they give you this. So what you're going to say is you say 3 tan squared theta, the one which they gave you, plus 5 sine squared theta is equal to 9, right? Now, what is that? What is this 3 tan squared plus 5? It is this thing now. So you got to replace and put this, okay? 8. So you say 8 sine squared theta minus 5 sine to the 4th theta all over 1 minus sine squared theta. So all over 1 minus sine squared theta is now equal to 9. Okay? Because we just saw in the last part that this actually changes to be this. So now you just have to solve. Let me show you how to solve. So basically, we would take, we break the fraction. There's no way we can solve with the fraction. So it goes to the other side. You remain with 8 sine squared theta minus 5 sine to the 4th theta is equal to 9 multiplying 1 minus sine squared theta. You get 8 sine squared theta minus 5 sine to the 4th theta is equal to 9 by 1. It's 9 minus 9 sine squared theta. Can you see this? Right. Let's see now. Here's what we'll do. We'll say the last, this basically, this is now a quadratic equation. And we call this a hidden quadratic equation. Now, quadratic equations are easy to solve. You always need to make sure one side is 0. So this has become 0 because we need to take these guys to the other side to make them positive, the highest power. You see it? So 0 will now be equal to 5 sine to the 4th theta. Then you have this, you can start with this 9. It's minus 9 sine squared theta. This 8 is coming to also subtract, so minus 8 sine squared theta. Then plus 9, because this was a positive 9 already. Can you see that? I don't know why. Excuse me. So it's like plus 9 because you had a positive 9 already, this positive 9. So now you will say 0 is equal to 5 sine to the 4th theta. Minus 9 minus 8 becomes minus what? Minus 17 sine squared theta plus 9. So here you have your quadratic equation. You can rewrite it to say 5 sine to the 4th theta minus 17 sine squared theta plus 9 is 0. Now here is what you do with quadratic equations that are not quadratic. Let's say you have an x to the power 4 or sine to the power 4, whatever. You always make the middle term here be your x, okay? Be your new thing. So you let x be equal to, or your y, or whatever letter you want to use. Let x be this middle one. Let x be sine squared theta, okay? Automatically, it will mean that x squared will be now sine to the 4 theta. You see? So 5 sine to the 4 theta, because x squared, it will be sine squared theta all squared, okay? Which means x squared will be sine to the 4 theta. You get it? So you now say 5 sine to the 4 theta is 5x squared minus 17x plus 9 is equal to 0. You now have it as a quadratic. Can you see that? Which means you now solve the quadratic equation. We have the quadratic formula, so we are fine. We need to know what is our a. It's 5. What is our b with its sign? Negative 17. What is our c? This one? 9. And what is the first thing you find? Discriminant. B squared minus 4ac. So you see if there are any solutions. Sometimes there are none. So it's negative 17 all squared minus, in brackets you say 4 by 5 by 9. Which is, what is the answer there? 109. Oh, good. So that means the solution is there. If this comes out as negative, you say there are no solutions, okay? Now we'll say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, which is minus of what is our b? Negative 17, minus of negative 17, plus or minus the square root of 109 all over 2a, which is 2 by 5. So there we go. It's 17 plus or minus root 109 all over 10. Now you can find your solutions. X is 17 plus root 109 over 10. What is that? Or x is 17 minus root 109 over 10. What is that? $2.74. Yes. Then the other one. 656. Now you will come back and put it here. You remember? You come right here. This is the most important. You say x is equal to sine squared theta. Right? That's what you said. You said let it be, right? Now, but then you need to do some alterations. Yes, we know that's what you let, but we want theta. Remember, sine squared theta is actually x is equal to sine theta all squared. But we just write it this way in trig. You get it? So now we can take the square to the other side. It will be the square root plus or minus root of x is the sine theta. Okay? And what we actually want is theta. So you say sine inverse of the plus or minus of root of x is your theta. Okay? So let's start with x 2.744. So let x be 2.744. That means you can say theta is equal to sine inverse plus or minus root of 2.744, which means theta is equal to sine inverse root of 2.744, or theta is equal to sine inverse negative root of 2.744. What are the solutions? Theta is what or what? It's saying math error for this one. So no solution. And then no solution. Really? You know why? Because sine theta cannot be bigger than 1. You get it? Sine theta is, remember the graph, it's from minus 1 to 1, okay? So you can say, so we actually wasted our time. We might as well just remove it. You can say theta is sine inverse of whatever. And this, you would now say, you can say sine theta is plus or minus root x, which means you can say here, say sine theta is equal to plus or minus root x. We can say here, let x be 2.744, which means sine theta is equal to plus or minus root of 2.744. And this is no solution. You can put in where it said no solution. There is no such thing. Now you can say let x be 0.656, which means sine theta is plus or minus the square root of 0.656, which means, what is it? Sine, you can now say theta is sine inverse of root 0.656, which is, or you can say theta is sine inverse of negative root 0.656, which is, what are the two solutions? What are the two solutions? -54.1, and then the other one, degrees. -54.1. Well done. So here you have it. These are your theta values and you're done. Can you see how easy this is? All right, here's what I should help you now. How to find solutions. They said between 0 and 270. Can you see this? Okay, so basically what you do, you now you can use what we call the cast diagram. Okay? 0, 90, 180, 270, 360. So that means this negative 54 point whatever is not in the solution set. But if you find this 54.1, you can use it to find everything else. Okay? Because if you look here, sine theta was plus or minus this. Is it true? So we are going where we have sine theta be positive and where we have sine theta be negative, right? Can you see? The solution which we are going to use, 54.1, this is when sine theta was a positive one, right? Was positive root 0.656, which means sine theta was a positive one. So we'll take here where it's positive. It's only in these two. 54.1. And if you want to find the other one, you know what you do? The other one is here, because this A, let me show you. This A means all of them are positive. We want to take where sine is positive on cast. Okay? So you are either positive in O, or you are also positive where your name is. So can sine be positive at C? No, because sine is not there at C. This is cos. So sine will be negative here at C, right? Can sine be positive at T? No, it can't be positive at T. Only tan is positive at T. Okay? Can sine be positive at S? Yes, because it's so sine is positive here. We'll take this because according to what we had, sine theta is positive root 0.656. That was the answer we took, right? So now it should be positive. And also at A, all of them are positive. So we also take here. Now, if you have found that the other solution is in quadrant number 2, the next job will be, how do I find a value in there? Now, how you find a value in there is always this way. You always remove the answer you have from 180. Whether it's negative or positive, we don't care, okay? So here it's what? It's 54.1. You have to remove it from 180, okay? So you say theta number 2 is going to be 180 minus 54.1 because we are going backwards. So 180, then you go backwards. You understand? And what is that solution? What is that answer? 125.5. Point what? 9. Yes. Now check the solutions that are in your books and tell me, what are they? Check the solutions in the solution manual, in the marking key. Tell me, what are they? This is number 7B. Yes. Yes. All right. If you want to find 234.1, you use the other theta, which you found was negative 54.1, right? Negative 54.1 was the other theta, right? But it's not in the range because they want it to be between 0 and 270, right? But basically, what you'd be now saying is, I now want to choose where sine theta is negative. Isn't you found it to be a negative? So now we want to use where sine theta is negative. Which quadrants are they? Quadrant 3 and 4, right? So, but we cannot take quadrant 4 because it's bigger than 270. So we'll only take quadrant 3, right? Now, here is how you get answers in quadrant 3. You always add your answer to 180, okay? So the theta number 3, I don't care whether it was a negative 54.1 that you were using, it doesn't matter. So you'd say theta number 3 will be 180 plus 54.1. What would it be? You should get that answer. 230, 234.1. That's the final solution, okay? Good. Right, I'll train you more and more and more. What is the other thing? Are you fine? Pardon? You're fine. Oh, really? Okay. If you say so. You give me an update after your test, right? You have to give me an update after your test, how it went, and then we start working from there. But we have started well. We have room for progress, so we should be working 24/7. I'll give you more questions, and we'll see how it goes. All right. Cheers, Rivimbo. Rivimbo. Wait.